Hey everybody, welcome to wasmCloud Wednesday for Wednesday, April 30th. We have a pretty good agenda for you today. Should be fun. Got a demo, a couple discussions, but there's something even more special than our planned demo, which is an unplanned demo, which we'll get into here in just a minute. So before we go ahead onto the agenda for today. Milan, I think you've been active in the wasmCloud community for quite a long time. I think you've been in a community call before, maybe a little while ago. But would you mind doing a quick introduction and then, just talk about how you found wasmCloud and stuff, and then you're welcome to go right into your demo.
Yeah, absolutely. Milan Raj, I'm in Austin, Texas. I'm at National Instruments, Emerson Test and Measurement most recently. Um, and yeah, I've been playing with WebAssembly on the front end stuff for a long time. We make a graphical programming language and compile out to web applications, WYSIWYG, drag and drop UIs for engineering applications. So we've been playing a lot on the front end with WebAssembly and been experimenting more with using WebAssembly in the back end now that we have P2. That was kind of a nice, exciting breakpoint. So what I've been doing for a couple of weeks has been trying to see how much leverage we can get from existing libraries and frameworks within WASM components. I've been focused on TypeScript specifically. So got pretty far on that, was humble bragging in the Slack how I can render JSX components, JSX with WASM components and JCO. So got called out on it and put up my example and can share it today. And yeah, I could jump right into that. So let me see if
I
sharing the
gave
screen is
you
going to work out.
screen sharing, so it should work probably. Nice.
You
Hey,
could see
look at this
yourself.
handsome
Excellent.
guy. Yeah.
Yeah, there you go. So the repo I put together, hosted up here. So WASM component examples, and actually I was just in the JS community meeting where the library I was experimenting with, Hono JS, came up there a couple of times too. So it turns out, and I just pushed these updates to the README. Fermion's blog has an example of using Hono with their JS SDK. And then wasmCloud has an example of using Hono pushed a couple of days ago, which I just saw. So that was great. And we talked about it. And there's actually a pattern that I'm using in mind that we might want to update in here where we could actually simplify the bindings quite a bit. You could do a lot. You could change some of the adapter code that's needed in this folder to a single line, which is pretty exciting. And there was also in the bytecode lines directly, there was a sample project push there. It's using a different router instead of Hono. It's using IDI router, but very similar ideas of we're actually able to leverage more and more things right from the JS ecosystem to make WASM components with JCO and TypeScript. So the direction of this example that I wanted to show off was what I've been exercising is trying to get more of the advanced features of Hono JS working. So in this project, the README is pretty straightforward. Have a very new version of Node.js. I just wanted to play with some of the new features in Node, like the out-of-the-box TypeScript support, experimental support, and the new, instead of npm run, this node dash dash run flag, which saves you 300 milliseconds, which is time I'll always take back. You'll need either whackage or wash in order to fetch dependencies, which I'll put out a call. That would be great if that was part of JCO out of the box. So that way I could just call into those to fetch them. And then WASM time, wasmCloud, whichever runtime you want to actually test things against. So one big thing I did for structuring the examples I'm hosting here is that I wanted to make it so that you could run them both in Node.js and with WASM time or wasmCloud in order to help with the development workflow. I could actually have an environment. I could set breakpoints, step through, debug, and do both. So each of these examples where possible. So I'll jump into the fancier demo of the Hono features app inside of here. If you look at the source there, that adapters folder that we had in the other spot, turns out you could actually replace all of that content from that wasmCloud Hono demo with app.fire here. And what app.fire does is it registers. If we go to the source implementation, it's pretty quick. Oh, wait, no, that's not the source implementation. If we go to source implementation, source definition. No, it's weird. There we go. It's pretty quick. It's leveraging, instead of calling into the WASI HTTP API surface area and trying to build up objects to represent request and response, it's actually just calling into the fetch event feature that's part of componentized JS. There's nice high-level wrappers around it, so you can code go off down to 4 lines or even just 1 line, which is great. And then the nice thing there is the Hono app itself is coming from this import libapp, and I could use the same one from Node wrapper, just pull in that same import and have the whole application runnable in Node or runnable as a component. So when I look at that, and I'll go ahead and start it. Hono features. So the features I want in there kind of spelled out here. And actually, I'm just gonna, I'll just start with Wasm time for the moment. So pull this up. So first, the nice thing about Hono, it's a fully, it has a lot of common features that expect from a web framework nowadays, like you'd see in Express. It can handle cores and has its own concept of middleware. And then built on that, there's actually a pretty solid ecosystem of components available too. So my goal was to exercise some of these more complex workflows and make sure that they can function. So the hello world workflow is, oh, can I return an HTTP response for whenever you hit the root? Can I make a request to a different service, make an outbound HTTP request? This is kind of like the proxy concept, be able to make a request somewhere else, do something with that response and return it. So that's what's being done here. Is this just hits http bin.org/JSON, gets the response and returns it. And then there's a couple other endpoints defined, but actually I just want to show one thing that's kind of fun. Right here, this show routes command is executed not as part of a route, but as part of the JS file execution. So actually, if I, and this is just fun, so I just want to show that. But if you were to, when you build this component for the first time, it's going through the JCO toolchain, and because that code actually runs during compile time, you actually see it when it's doing the snapshotting and stuff at compile time. You see it snapshot all the routes that are defined in this application, and then that's what actually gets snapshotted into my Wasm component in the end. I just thought it's just fun to see that show up at compile time instead of runtime and make you realize, oh yeah, there's all this stuff I could do. I could cache some tables or whatnot during build time of the component and have it just ready to go at runtime. It's just fun to see those concepts show through. But yeah, so if I start that one again, so the root route, not too exciting. The JSX route. So what that one does is, if I say JSX hello Milan, this is super simple. But what this is showing, if I go to that app definition, you could see pulling a parameter off the URL for the JSX route. If I don't include anything, it'll return unknown. And then it goes in and renders a JSX component. And you could see it has strong typing for props and everything. All TypeScript is wired up as you'd expect. But this is calling into a JSX component definition. So I could go there and see JSXy related things. So I can have server-side rendered components, build up a web application that way, as an alternative to like hosting static file content and rendering that out. Both are great, but the main thing here was to show that you can integrate it. And it's just following the out-of-the-box tutorial stuff from Hono. So they say, go in your tsconfig, swap out JSX for React JSX and JSX import source for Hono JSX, and all just works, which was been the most exciting thing about going through all this, is that all these demos just work. This next one, didn't necessarily just work out of the box, but now it does. I submitted some patches upstream to the OIDC middleware for JCO. So what this endpoint does, if you go to that one, is here I have it plumbed into Google Auth for OIDC. So it creates a couple of endpoints. The root endpoint is gated on having auth available. So here, when I went to, just show it quickly one more time. If I go to the OIDC endpoint, it's gated with auth. I'm not logged in right now, so it's going to redirect me to log in to my OIDC provider. In this case, it's routed out to be through Google accounts. So, all right, I need to log in. I could log in, approve this connection, and now when it's going to that same route, it is authenticated. It's allowed to go through this middleware successfully passed, and it was allowed to go through this time instead of redirect, and it returns my current auth session information. And this plugin is particularly handy as really bare bones OIDC implementation, because the way it's designed is to handle all the cookie management, or handle all the OIDC token management through cookies. So I don't need to set up a separate store or rely on KV or anything in order to persist that cookie state. It allows you to use cookies as the workflow. That's the default workflow out of the box. So it works. It just works. I'm logged in. I can log out, which are the only two endpoints I've implemented. And then I need to log in again if I want to use it again. And then similarly did a similar kind of pattern for GitHub OAuth. So those are different plugins. This one didn't require any changes. The existing middleware worked out of the box. Is it OAuth? Yeah. So this one is created tokens on GitHub, made a GitHub app. I can authenticate against that and start calling into the API and pull info about my GitHub account, which is great. And then the last major demo was that their proxy config worked out of the box too. So here it's proxying all requests from here to http-bin.org. So then I could just hit the JSON endpoint of http-bin.org, which has been kind of slow for me today. And there it goes. It's the same request as that the front page does, but it's proxying the whole API from HTTP-bin. So those were the major component demos there. And then the last big thing I wanted to show was it's plumbed up to be able to run all the exact same demos via Node. So same things come up. Yeah, HTTP-bin's kind of slow, and that homepage relies on it. But I could actually set breakpoints in VS Code and whatnot in order to debug the application that way. And if you have the time, I could actually show another demo, which is kind of fun.
Sorry, you're debugging it, the Wasm, or you're debugging the JavaScript?
Debugging the JavaScript
Yeah.
version of the Hono application in Node. Yeah.
I don't see any reason to stop here. Good.
Yeah. The other one that was fun is the Hono OpenAPI example I put together. So what this one does, and everything's already built, so I should be able to just start. I'll just use it again for now. So the Hono OpenAPI demo. This was just me. This is just, I don't know. Now we're just going to learn about Hono. So Hono JS has another middleware package, or a third-party package that lets you do typing around your whole API surface area. So you export, instead of creating a new Hono object, you create an OpenAPI object, an OpenAPI Hono object. And once you do it this way, now instead of defining your routes using the existing Hono API, you use this app.openAPI, and you get really strong typing of the context of all your parameters around it. And the reason you get that is the way you define your routes now are, with this example, using Zod for typing. So Zod OpenAPI to create routes. So you create your Zod types of all the inputs and outputs that are allowed. And then the nice thing about this approach is it can include documentation. So you can see OpenAPI doc definitions in here and examples. And then the lovely thing is when I do c.request valid param, in this case, I get strong typing back about like the inputs and outputs of things. It knows, hey, I need to return. It'll complain to me if the type definition is supposed to return a field that is missing. Hey, ooh, lovely type problem. You need to include a field. Okay, so I could make sure to include my field in my JSON response. So you get strict typing in and out. So the way this looks when it's running is here on the root of the application. I'm rendering out a Swagger doc, and then the actual doc, the OpenAPI documentation JSON is at this endpoint. So the UI is told to point to that endpoint in order to render the docs. And now I can actually test out these different routes. So I could test out my stats route if I want, try it out, send values across, get responses back. And then if I'm missing fields, whatever, is it reset? No, I thought I could edit this. Maybe. Oh wait, no, yeah, reset and then execute. Get back the OpenAPI middleware is handling all the parsing and stuff for me to say, hey, you're missing your types. So saves you a lot of boilerplate work. So that was the OpenAPI one. And then on this example specifically, I also instrumented up benchmarking. So you could actually, I won't run through it, but you could like start the Wasm time server, start the wash server, and then just hit it with the Apache benchmark suite and get some nice high-level stats about how fast things are running. So yeah, I think that's most of the examples I wanted to share.
All right, Milan, I think we're gonna have to institute a new rule. Because I had a demo planned after this, and it's just not cool to come in and like do all this and just like
I am
show.
so excited for your demo. You do not.
No. Sorry for the jokes. This is awesome. This is really, really cool to see a fully featured JavaScript example. And I'm glad you talked a little bit more about Hono. I think my only I guess I had two questions, which I may have missed, but what about Hono makes it so special that like all of this kind of just works when we bring it to Wasm? And then, well, I guess I had another question, but that's probably the more important one.
Yeah, so Hono is designed, their whole spiel is that they're built on top of web standards out of the box. So their middleware approach is just passing around like standard JS fetch-based request response objects. They have a built-in out-of-the-box support for service workers, for the browser-based service worker API using fetch event, which just happens to be also the API used in componentized JS. They offer that as an option for implementing servers. So because they're like hard focused on being standards oriented, building on top of browser standards, building on top of JS standards, it actually makes it really easy to plug into other runtimes. And it's a project that came out of Cloudflare for their workers. But they're like, we're standards oriented. All these other projects are standards oriented. So they have adapters for Fastly, Cloudflare workers and service workers and Node and just all the JS runtime environments. They just have a list of like 10 JS runtime environments they work in. So by being standards aligned, I think that helps. And I think it'll be cool to, at some point, I was talking in the JS community working group about, hey, how do we get to plug in componentized JS /JCO /Starling, whatever we want to call it, as the runtime? How do we get that on their list of supported runtimes? And even a couple of things like they have built-in env support for checking process environment variables. We need to actually contribute some code to actually get environment CLI env pulled in there, or one of the other secrets or something. But whatever that backend would be, it'd be cool to start integrating that first class in those frameworks. But.
Yeah, awesome. Um, I well, I had another one, but I'll jump to the back of the queue. Liam.
Milan, wow. I mean, I know that I taunted you on the demo, and man, talk about delivering. That was I really, really love that whole demo start to finish, and so much stuff that that Cloudflare's been putting out lately has just been top notch and amazing. So I love to see the alignment here with WebAssembly. It makes sense given workers or V8, where what they're thinking. Wouldn't surprise me if they're using similar tools on the back end, considering we're all kind of converging on the same standards here, which is great. And my question is what's the size of the artifact that this compiles down to? You mind sharing any details there? Like how big's the WASM? Did you do a debug version, like a regular version? What's it look like? And
Yeah.
and then my next question is cold start time, like any testing or anything like that?
Yeah, I could have more numbers next time maybe, but
All right.
I think I was saying on average the start time is incredibly fast, like a couple milliseconds, a millisecond or two to actually like service out and respond to the request. All of the examples I've shown are not well primed for a raw benchmark because they like proxy out to HTTP bin, so that's completely dominating the response time is that network request. Those stats examples, when I ran benchmarks in there, an interesting, so how do I want to say it? The initial time is very similar to the initial time. So the stats example is built on all that OpenAPI infrastructure. The benchmark was, hey, let me pass in 10,000 numbers and then run the statistics calculation on it. Type validating 10,000 numbers in the OpenAPI sed-based infrastructure is kind of slow. So maybe this is getting too nuanced, but when you do that, if you start a node process and do that first execution and then the first execution with the WASM process, they're about the same amount of time to execute. But the benefit that node gets is because it's dirty and not creating a new instance per request, it actually starts JIT optimizing and getting faster and faster and faster until it's about 10x faster. If you remove all of the ZOD validation stuff, it ends up being almost identical in performance as the node process, even the node process warmed up. Maybe about half as fast, but that's like 1 millisecond versus 1.5 milliseconds or something. So really fast. The component sizes, so the Hono features one right now, that one is about 13 megabytes. I also was experimenting with AOT compilation, and that blew up very large, and then I stopped looking at AOT compilation at that point. Yeah. But it's like 8 to 13 megabyte. I think the bare bones, actually I have it in a folder and I can pull it up in.
And is that with, it sounds like all the assets all compiled in as well. So
okay. Yeah.
All right.
So the Hono features one was 14 megabytes snapshotted. So it probably is also initializing more junk in heap space when it snapshots. The Hono bare bones one was 11 megabytes. And then the non-Hono super bare bones one is not compiled, I guess. Oh, wait, no, it is compiled. Was 11 megabytes too. So
okay, thank you so much. Fascinating. Yeah. Certainly a lot to research there and play with. Thank you for that.
Yeah, it was fun to come across. It's almost like because I thought I was doing this by myself. When I added that example to the repo, but it's almost like simultaneous discovery.
Right.
We both came to the same conclusion, and then I come in there with this demo because I basically did the one from the WasmCloud one in the working group meeting, and they were like, "Oh, you didn't even need this extra stuff that you've got around it," and Milan has already discovered that same thing. So it was cool to see that. It was awesome to even just like doing it the way I did, which is the one that's in the WasmCloud repo. It's still like pretty awesome to see how easy it is to run TypeScript compiled down to JavaScript that actually just runs inside of Wasm. It's really cool. It's awesome. And I'm excited to see what tooling takes shape in the ecosystem around like what are the things that would be just nice if they just worked. And like Milan was saying, like the environment variables one is neat as well. And there'd be some fun things that we could do around that. We did sort of start the conversation in the working group around like what does it look like to actually take um, environment variables from like config runtime or something and actually just um, have Starling Monkey, which is the way that JavaScript runs inside of Wasm, just automatically detect that and know that and pass that through to stuff like Hono, so that we can just have it live there and be ready to go. So yeah, it's cool. And I'm sure there's going to be rapid development on a lot of this stuff. So it's like even 6 months ago it was not this easy. So it's cool to see the progress happen that quickly.
Amazing. Folks, what other questions do you have for Milan? Actually, Milan, there was one question. Would you mind posting the link to your repo if it's public in the chat here? Feel free to cross-post that in the wasmCloud Slack as well. I'm sure folks would love to, take a closer look.
Yeah, absolutely. And we could also talk about like what it would be to inline some of those examples to wasmCloud templates or whatever. But yeah, for sure. And I'll paste a link right now.
That was actually going to be my question. So around the OIDC example, I noticed that there were some secrets that are that you're getting it from there. I didn't know how, if you were compiling those in the component or pulling them from like the environment provider.
Yeah, currently I am compiling it into the component because that was the easiest way. Yeah, I know. That was the easiest way in my dev environment to get like, because my thing about wanting like, oh, I want Node and Wasm time and Wash CLI, like I want to be able to run in all these runtimes easily. So that was the quickest way to do it initially. It's not horrible. It is horrible, but it is. I did use the .env rollup plugin, so that way it's at least not checked into source. There's a separate .env.local file, but it is compiled into the component asset that is generated. Not ideal. I do want to explore with the thing that was blocking me from trying something like WASI secrets or even just env variables was if I wanted to get to run in the node context as well, how do I like shim out those WASI env imports and like polyfill them to call into like process env or to .env in node or something. That is a thing I want to do next. I'm not advocating what I did as the way to do it in production, but it was definitely handy for a developer workflow locally.
Yeah, for sure. My intent was not to trap you into revealing secrets. It was just that I see definitely potential there for integration with like the wasmCloud secrets interface, getting that upstreamed as WASI secrets, like doing it in a standard way from environment variables, like all those things are all really, really huge things that I would love to work on the wasmCloud side. It's cool.
Yeah.
Someone, well, folks, if you have any other questions, let me know. We'll let Milan know. But Milan is in the wasmCloud Slack, so I'm sure that we'll have some fun, like JavaScript, TypeScript examples and discussion going on there, especially given like the recent buzz with Hono. But thank you, Milan, for coming on, taking the time, explaining, showing. This is I really appreciate it. This is huge for the just JavaScript ecosystem for components in general.
Yeah, I appreciate the push to actually do it. I've been sitting on the examples for a while, so it's good to get them out there.
Yeah, nice. All right, folks. Well, that's hard to beat, but we can go ahead and go on to our regularly scheduled agenda now. I think that we've got a couple good things to share. So let me go ahead and share the agenda. Hey, that's us. Okay. So for today, what we wanted to talk about, I had a quick demo on component instance. I called it saturation here, but it's really like the number of active instances metrics. And then we'll go into a couple discussion items, one for a pretty large PR that came into, or that I put into the wasmCloud repo earlier this week. And then I think it's well worth having a little time for us to discuss as a community on the statement to on proposed changes to the CNCF NATS licensing and ownership. So I appreciate all you folks for coming in today and being present for that. So the demo should be pretty quick. Actually, this came about with a little bit of collaboration with Milan, where we're talking about, hey, there's a question that I want to be able to answer about Wasm Cloud components, and it's hard to answer that question. It's like, how do I know how many instances of a component are running at any given time? How do I know what my max is? How do I know if I need to increase that number? These are all things that you would run into right when you start running components for real. And, you could just bypass this by setting your limit to unlimited, but better to, have a little bit more evidence there. So I think that the best way to start answering some of these questions is to lean more into our observability implementation. So what I did put together on in this PR is are two new metrics. One that is the wasmCloud host component active instances metric, which is emitted when you start a component. It's how many, like the max instances that you set when you run a component in wasmCloud, and then that's max instances. And then active instances is the number of components that are instantiated and running at any given time. So what this lets you do, if I drop over to Prometheus, all I've essentially done is, wow, looks like a lot. All I've essentially done is launched the Hotel Docker Compose example that we have in the wasmCloud repo, and then ran wasmCloud. Let's see, observability. I've run wasmCloud with the wasmCloud observability enabled equals true flag, which turns on traces, logging, and metrics, and then deployed KV counter. So this is just the example app that it's HTTP to a Rust component to the Redis database. And what we can do is we can take a look at the Prometheus metrics. An existing one is invocations total, which just tracks the total number of invocations over time, which is neat, but maybe not very descriptive for what we want to show. We can query component max instances, which we can see for this specific component, Rust HTTP key value counter. Our max instances or our max scale is set to 100. And then if we query for the active instances, we see that we have none. Like over the last 5 minutes, there have been no active instances executing. So if I throw a little bit more of a load at this component, say concurrency level of 100 at a time, do 100,000 requests, then Redis immediately snapshots. That's nice. Then over the next couple of seconds, as this gets exported, or as the metrics get exported to this Grafana instance with Prometheus, we will essentially see this number of active instances climb to the actual number of active instances, which is likely to be actually less than 100 because of how quickly like the WASM just opens up and then completes execution. So we'll give it a second. I know that this like does a heck of a lot with logs in the background. So maybe I can let me kill this and just let it catch up. So we have active instances. Come on. There we go. Our active instances metric shot up to, looks like 22. So at the time that we exported this, little snapshot, we had 22 active instances. What this also allows us to do, which is really neat, is we can express this active instances and max instances as a ratio. And so I know that this is like baby's first Prometheus query, but I do like it. If we do this kind of change, it's no longer tracking it as a strict number, but this is a percentage of the max instances. So you can see when we were getting 100 requests concurrently, we reached about like 22% saturation of our instances. You can also use this for your alerting. So if we take something like this, and we set it to be greater than 0.8. I don't even know if this is valid. Oh, cool. Sort of. We can set an alert on something like this with your existing metrics pipeline to say, if I reach, 80% saturation, 90% saturation, send me an alert. Maybe something's going on. Maybe we're just getting high traffic, things like that. So that's really what this PR is all about. I know that when we set up metrics and everything in the wasmCloud host for 1.0, we essentially shipped it with a couple of baseline metrics, like a couple things to get started. So it's really nice to kind of get back to this code and enhance it a little bit. We have the precedent for adding these kinds of metrics. So if folks have other, I like to frame this observability, all the open observability stuff as like a way to answer some of the production questions. So if anybody has anything that's like, how do I know if something's going wrong with my component? Like how many things have errored? These are the things I think we should lean really hard into OTel for. So that's it. Only one demo. Very lame. Only a couple charts. Very lame. But do folks have any other questions or comments on the metrics? Alrighty. Well, this one will be, I guess I need to merge it, but this one will be coming soon to a wasmCloud near you, and you should be able to try it out. I think there's plenty more to consider on the observability side. So I think we're doing a little bit more investigation here of how we can do this better. So all good stuff. Okay. So we can go ahead and move on. I'm just going to share my screen one more time. Just for the last two discussion items of today. The first one being a fairly large PR that I put in yesterday, 2 days ago, yesterday. And for folks who see this and get scared about the number of lines of changes, I wanted to talk a little bit about this work because it is a lot, but primarily this is actually just a refactor. The intent behind this PR is to improve the embeddability of the wasmCloud host. So, as you all may or may not know, the wasmCloud binary that you run when we run in production or when we download it with Wash is actually a crate that just embeds the wasmCloud host crate. So embeds the wasmCloud host library. And this is something that anybody in a Rust project is able to do. You can just take the wasmCloud host library and embed it inside of your application. You can run components, set up links, all those things. There is a little bit of an issue with that. One is that we haven't exactly designed our host API to be embedded. Like there are missing functions to call on the host that you would normally be expecting. And that's because we primarily lean on NATS for the control interface API, for socializing configuration, links between different wasmCloud hosts, things like that. So the goal of this PR is to modify some of the host behavior to be essentially behind some common simple traits. And this can be as simple as something like for all of the events that we publish in wasmCloud, previously we had an implementation where it would publish to a NATS topic at wasmbus.ebt. But if you're embedding this in your own application, maybe you wanted to just get a channel and just get all those events essentially directly fed to you as they come across. Well, now the wasmCloud host just uses an event publisher trait abstraction, and you can supply any implementation. So a channel, you can turn it off entirely if your application doesn't need events and just make it that little bit more efficient. Things like that. Same thing for configuration and for simple data stores. If you didn't want to store those things in a NATS Jetstream bucket, for example, you can provide a hash map. And I know that a lot of this is given from the guise of a NATS implementation and a minimal implementation, but I think about this a little bit more as a, distributed wasmCloud implementation, which is essentially our default mode of running, and then a minimal dumb embedded implementation where the goal is to essentially remove as many dependencies and things as possible from the wasmCloud host. So just get down to like the basics of running components. You can customize the functionality of the host to meet the needs of your platform, and you can opt into things as much as you'd like. So there's plenty of there's plenty more work to do, but I was really inspired by the generics that the wRPC library gives us. So all of the transport that we do over RPC is done using the wRPC transport abstraction. And so feasibly, as we can add support for a more pluggable host that can support multiple transports, that means that you could have your workloads communicate over TCP if you so chose, or communicate over Unix domain socket. Like you get to program the Wasm Cloud platform the way that you want it to work. So that is what a lot of this is motivating. I think that this will drive a lot of interesting work we can embed with the Wasm Cloud host even better inside of Wash Dev to provide some implementations and customize it for the local development use case, and things like that. So TLDR, with this PR, there's a lot of lines of code that changed, but there are no breaking changes, actually no functionality changes at all from the binary perspective. Like when you just run Wasm Cloud, it does the exact same thing as before. But when you're embedding the Wasm Cloud host crate, you have a lot more knobs to be able to implement the functionality as you'd like. This does come with quite a lot of improved documentation as well. Let me see if I have that pulled up. But I tried to just basically shore up the host crate documentation while I was here. I guess I don't have it, but yeah, I appreciate any and all maintainers who are going to take a look at this larger PR, and happy to do like a pair review on this one too, just to talk through the different pieces. This was me validating the tracing work. Yay. So do folks have any questions on this PR? I know it's a big one. I didn't want it to just like come across and look really huge and out of nowhere. But that's it. Do folks have any questions on this one? Alrighty. Oh, nice. My patience. Hey, Masood. Yeah, go ahead.
Hello, Brooks. This is actually awesome, and I said that on chat too. But I want to ask a question about, something that has kept me a bit busy. I'm not talking about time-wise, but my mind is a bit inflexibility in the runtime that basically hard codes the wRPC implementations, right? Obviously, it has a good impact on the performance and using the engines store, all those sorts of good things. I'm not getting into them, but I'm just saying that it is, by the way of that implementation is limiting anyway. And in this embedding, what we're really embedding also is that we're embedding that limitation with it, saying that at some point this needs to also provide a bit more knobs in the runtime for us, because I have use cases that want to do alternative implementation of wRPC, but runtime does not cooperate unless I change it.
Yeah, exactly. I mean, I think that these were really low-hanging fruit like implementations. Of course we can't do it all in one PR, but that's exactly the same motivation, I think, to this story. the areas for the wasmCloud runtime where you don't have that customization knob should be few and far between, especially with wRPC. So I would love to design. I know that we can change the wRPC transport, for example, but I'd love to do some maybe additional thinking about how we can make that generic, how we can make that implementable by anything. My initial thought when coming up with this PR, when I considered wRPC, is it would be really cool for the host not really to manage links and targets and where everything is living in the lattice all at one time. It's a lot of computation for the host to do. It would be really great for the host to be able to consult a simple abstraction, just be like, hey, this component is trying to call a function on this interface. Where do I send it? What do I do? And we have the option to have that be something that calls a component in memory. We have the option to give back a wRPC NATS transport to send the function over NATS. We have the option to have return an error and say that that component's not allowed to invoke that target. I that's the experience that I want to drive to. So Masood, maybe just let me ask you back. Is that the kind of goal that you're hoping for too, or is it something a little bit different?
Well, obviously, the choice in transport is quite important. Again, myself, I do have use cases that would benefit from alternatives, right? But I'm just saying that if we could also, similar to this, allow in runtime that I could have my alternative implementations of those WASI interfaces, then that gives me more control about how my custom host is behaving. That's what I mean.
Okay. So even like a level deeper than that, but you may want to, you may want to change like
I'll
I
give
can't.
you a good example.
Yeah, thank you. Thank you.
If you implement an all-in-one, let's say NATS provider, object store, key value stores, and other things, this will unlock a couple of use cases. It's less setup for some use cases that don't need a lot of separated bandwidth and those. And also it gives you the option of doing that if you want to. But more important is that the fact that you're implementing together, it gives you an option of doing things that you cannot do when you're doing them separately. Because at the moment, for example, we don't support provider chaining, right? And that means that I can't like, just pass something from one provider to the other provider for further processing unless I put a kind of a plug, a component as a adapter in between to facilitate that, which I'm also doing. But I'm just saying that these kind of make implementation more complex for just because of the way that it is right now.
Yeah, yeah, I think that it makes sense. A lot of good ideas there. Um, but yes, I would love to look like all the way down the wasmCloud stack and just start adding in additional places where you can plug and play this because that's it's part of our whole value prop is that you can extend wasmCloud at runtime with these components and providers. You provide all your own functionality. So let's just keep adding more and more where we can. Um, Vance, you had a question. Is wasmCloud becoming more polyfill over time? Did you want to expand on that a little bit? Sorry, I'm not sure if you're in a place where you can talk.
Uh, yeah, just it does seem there's a bit of a trend there. We, as like wRPC becomes a, a, a standard and really moved out. And I think it's a positive thing, right? Like, I mean, more and more, let's have a bunch of standards that are accomplishing this communication and enablement of what we're trying to do.
Yeah, yeah. Yeah, I just wanted to make sure I wasn't making any assumptions, but I agree with that. I think that wasmCloud should strive to be a pluggable, extensible platform wherever we can, and doesn't make it intentionally obtuse with abstractions, but wherever we can, just to enable more use cases and people customizing it. Just really lean into like what we do well as a project. I think we definitely should be going in that direction. All right, well, I know that we just have a couple more minutes left, so I'm going to go ahead and transition to the last discussion item. Thanks, folks, for letting me talk about a big old chunky PR. The last discussion item is around our blog post that we put out earlier this week, late last week, on our statement on the proposed changes to the CNCF NATS licensing and ownership. I would highly recommend folks just give this one a read. We put this together as maintainers first, or as org maintainers first, just to make sure that we stayed on top of some of the story, because NATS is one of the only things that wasmCloud really took a stance to integrate tightly with. I mean, if you take a look at our ADRs, 0, 1, 2, 3, use NATS for the lattice, right? Like, we've been using NATS as a core part of our platform for quite a long time. And really, the whole point of this blog post is just to say that we're not worried. We are dedicated to the CNCF as a project. That's what we believe makes this such a powerful community, is to have all of these open source projects that work together. NATS itself is, there's lots evolving in that situation about where the licensing is going, what the repository structure is going to be, who's taking ownership of the project. But it's worth noting that we plan on supporting NATS as a way to do transport and distributed communication, no matter the endpoint. Obviously, I'm preferring to keep it as something that is Apache 2 licensed so that we can stay all open source. But you can see that we have essentially some precedent already about projects that have done similar things, like our Redis key value provider that works out of the box with Valkey and Redis, or our Vault secrets provider that you could use with OpenBow, what have you. This is really from our perspective, just to reassure that Wasm, this is not a threat to the wasmCloud ecosystem. We are going to keep building the best project that we can for running WebAssembly in a distributed way, making developers happy, and being the best runtime for Wasm components. And we have been designing our platform around these pluggable abstractions, as you can see, more and more coming up lately, that allow folks to have options in the case that they want to take a little bit more control over their infrastructure and routing and planning. So it will be completely valid to use wRPC over TCP to hit, maybe another container in your Kubernetes cluster, or to use wRPC over Unix domain sockets if you're running everything locally and you just want that raw performance. Would recommend taking a look at the talk that we did last year. That was last year, right? Yep. Last year on wRPC, if you're interested a little more in like the fundamentals of the project and how it works. But as we have talked about already a little today, we're already working on making our wasmCloud host slimmer and pluggable that lets you choose to use the NATS implementations, which isn't going anywhere, or choose to maybe use different default implementations. So there's plenty there. Yordis, you had a question. What are the consequences when it comes to dependencies with like watching in the KB bucket, that kind of thing? Yeah, all of that is covered. That's a little bit of the planning that went behind this trait pull request. So, configuration, data watches, you have the option for, a config manager, for example, to support a watch. You can essentially send updated values into a channel if you weren't watching a Jetstream bucket, things like that. Really a big part of this was to find the NATS specific isms that we tightly depend on and see what could be implemented in a different way as an option. Again, just want to reassure that NATS isn't going anywhere. It's still a really core piece of our distributed story. It provides a ton of power when running in distributed environments, when meshing a bunch of wasmCloud hosts together. So we'll continue to support those modes, and we're just watching eagerly to see the situation resolve around the project. So I know that this is a little bit, this is maybe a little bit of a delicate topic, but we're all here as org maintainers, longtime wasmCloud stakeholders. Folks have any questions, anything they'd like to express about this, anything that we didn't answer in the blog post?
I guess how close do you feel like could you run completely decoupled from NATS at this point, or there's still what are the pieces that are still coupled?
Yeah, I can actually show you a little diagram to help out with that. So, no, not yet. And there's two main pieces that we are that we are tightly coupled to NATS for. This is my attempt at drawing out a wasmCloud architecture diagram. Hopefully this is a reasonable size, but in the wasmCloud host, we have things like basic configuration, OTel traces, logging and metrics, our runtime, which is where WebAssembly is, and then our native binary provider API, which sends links, config, updates all over NATS to capability providers that are essentially spawned by the host process. And then we have all different pieces of the wasmCloud infrastructure, like watching for links in a KB bucket, subscribing for control interface messages from NATS, our secret store, and our policy service are all messages that go through the NATS message bus. So all of these things are what we essentially the host is using NATS for in a tightly coupled way now. Actually, after the trait pull request, the story is a little bit different and a little more interesting. So inside the host, all of the basics are exactly the same, but all of those pieces where we had we were using NATS APIs directly, but maybe didn't have to. Are now abstractions. The data store, the control interface server, the config store, secrets, policies, and events all have lightweight abstractions. I mean, really simple, like the data store is get put delete, right? That was all we're using the Jetstream thing for and watch. But if you don't, you can update your own watch semantics. And the NATS implementations are still in tree with wasmCloud. And by default, when you run the binary, we're using these NATS implementations over the trait abstractions, and they work exactly the same way. Now, the only two things that we are still tightly coupled to, and I'll provide reasoning for both, is the native binary provider API, sending messages to capability providers for like, here's the links, here's the config, and wRPC, all of the messages that flow over RPC. Now, as we called out, wRPC, the transport, is already a pluggable abstraction, something that we can, instead of giving a NATS transport client, we can give a TCP transport client, and everything would work the same, assuming you have like a TCP listener on the other end. However, none of the existing providers are exactly in a place to listen over TCP. It is the same abstraction on that end. We just don't have a mechanism for like to flip a switch so that a provider listens on a socket or a UDS instead of a NAT subject. And then when it comes to the native binary provider API, this is something that I think we've known is a little leaves some functionality to be desired for a little while. The fact that wasmCloud spins out binaries on the host where it's running is nice for simplicity, but ideally we like to run capability providers in a couple of different modes. So I think that on the capability provider side, there's a little more of a redesign we'd like to do around how providers get messages, around how we can be sure that provider received a link, it got configured correctly and spun everything up, or you can send an error message back. There are just a couple of things we'd like to improve there. But really, the biggest part that we just need to address here is the routing to different targets that are running that are known to a Wasm Cloud system in a world where you can't just publish directly to a topic and have it get routed magically anywhere to where it's going. So, all of these have different modes in I'll speak, a little bit more to what we see on for folks who run Wasm Cloud at big enterprises. Often they're running inside of Kubernetes. Often they have some kind of Istio or Envoy or mesh, service mesh that's all addressed over HTTP that they already can hook into for their routing. So being able to hook into that is a desirable property for people running this at a scale that at a large scale and where they already weren't invested in NATS, I suppose. So the options there are just, I think, naturally where the project goes. But Milan, I hope that answered your question about like where do we depend on the project and kind of what's left.
Yeah, absolutely. Thank you.
Brooks, do you plan to add these diagrams to our docs, or are they already part of the docs?
Not part of the docs yet, but I would love to get them up on the docs. Yeah, I think that a flat architecture diagram of different like Wasm Cloud, like what the host is uh, something that would be valuable for sure.
Yes, actually, I was looking for such diagrams when I started with Wasm Cloud, so it would have been quite a help.
Amazing. Yeah. Thanks for the call out. I will definitely make sure that, we'll get this, pull requests, any comments and reviews and everything, things we could do better, change. But then I think that this can go right into like an architecture section on the docs. Wasm Cloud 1.9, baby. Best Wasm Cloud yet.
Yeah, I just want to comment on after the first shock of the announcement. From the perspective of Wasm Cloud, I think it actually makes it over the time a better product now, because the putting in such an abstraction layer forces clear kind of separation of concerns, and I think it's just in the end it will for the benefit of Wasm Cloud forced to do that, right?
Yeah, thank you, Jochen, for some positivity there. Yeah.
Yeah, and thank you for all the work that that is put into that aspect right now. Although it sidetracks now other things that were probably higher on the list to do, right? But I think it's for the benefit. So, thumbs up.
Yeah, thank you. I hope it is too. I hope that I'm very eagerly watching what is happening on the, on the whole situation. And I think that we'll all, as Wasm Cloud maintainers, just keep in mind the best thing that we can do for the project. And yeah, I know that we're doing some exploration on abstractions and confronting assumptions and all of that, but rest assured that, for Wasm Cloud 1.0, the defaults don't change. We're going, we're doing everything over NATS just like we were before. There's nothing really to worry about there on the implementation side.
Yeah, and I can just speak for us, Machine Metrics. We're going to stick with NATS, obviously, because it's the best technology by far. There's really no alternative on that front for IIoT. I think it's very hard to replace it, but it's also we would choose it again, no matter what the outcome is here, right? So, yeah.
Yeah, thank you for coming in and talking about that too. It's really useful to hear, which obviously I know that you all are using Wasm Cloud and NATS and everything, but it's great to just, get the perspective of the power users, because it is a very unique technology.
I have probably a unique take on it. Because I come from the Erlang world, right? And this is the world I've been living in for 25 years, and in all that time, I've always been an outlier, really, because that's not a mainstream community. And so the challenge in working in that community has always been creating these low impedance bridges to other technologies, right? And so a lot of the effort that we end up spending is on creating those bridges. And I'm looking at this as a great opportunity for creating a great bridge between this Erlang distributed concurrent environment with Wasm Cloud and WebAssembly. I'm quite enthusiastic about it.
Yeah, thank you, Vance. I'll take the enthusiasm. Wasm Cloud Elixir host v2, baby. Sorry. I did actually, all trolling aside, I did actually see that the library that we used when writing Elixir, wasmX, does support WebAssembly components now. You can run Wasm you can run Wasm time in the Rust NIF in your Erlang app, which is pretty cool. All right, everyone. I know that we're over time, and this was a really important discussion to have. I mean, obviously, there's not too much to come out of it really at this point, but I really appreciate everybody for taking the time to come in when this is the agenda item and just just chat, get together, kumbaya, and realize it's all going to be okay. It's just software at the end of the day. We're gonna be all right. And let's just keep this conversation as open as possible. If anybody has questions, please feel free to ask it in the Wasm Cloud channel. Interests in direction or where we're going or what we're planning, all that stuff. We want to be as open as possible. So, yeah, I know that we just had our roadmap planning in the last community meeting, LOL Sob, but I don't think that really changes anything about. I don't think that really changes anything about what we need to focus on over the next 2 months. Certainly, nothing is moving fast enough to impact the current roadmap. So everybody can keep on cranking the way we've been going. Q2 roadmap it remains probably about the same, and looking forward to doing some more planning a little later in the year. So All right, everybody. Well, thank you again for coming today. We'll pick all the things up in Slack as usual. Milan, special shout out. Thank you so much for doing an introduction and all those awesome demos. It was really cool. Good to see everybody. Good to see everybody in the call. Yeah, but that's about it. Thanks, everyone. Have a wasmCloud day.